All right, we are in Chapter 1, Section 9 for IM1, and this is called Perfect Squares. I cut off the very tippy top of this page, so I can't see it there, but it's called Perfect Squares. So we're just going to keep practicing those pattern recognitions. Again, this makes the problems so much easier, so much faster if we understand and can recognize these patterns. So a perfect square trinomial is a trinomial that is the square of a binomial. So that means that it was either addition or subtraction, but it was just squared. And this is a very large space we gave here, but we're only going to have two pieces in there. Binomial means two numbers, right? So we're going to have a number plus a number or a number minus a number. So how do I know if it's plus? How do I know if it's minus? So let's look at these two symbols here. So if I have plus, plus, I'm going to have plus. Okay, that's kind of the simple thing there. If I have a minus and then a plus, and I'm doing color coding here, because there's a minus in the middle, I'm going to have a minus. So that's just the kind of easy way to recognize that. And with this one, what you do for the pattern is once you see that it's this pattern, it has to be a square plus, how do I want to say this? So it's the square of the first term. So if we have A and B, then it's going to be the square of the first term plus 2 times both terms plus the square of the last term. So we can see that fits perfectly in there. And so it's just this pattern, the way we want to recognize it. I don't know why I'm erasing that. That's perfectly fine to leave there. So if we recognize this pattern, all we have to do is take the square root of the first and the square root of the last and plug them in right there, and we're done. But we have to make sure that it is this pattern. So the first and last need to be squared, and then the middle term needs to be 2 times the first and the last. But it's the square root of the first and last. So it's a little bit harder to recognize than, say, the last one we did. That was just very simple. You just see square, square, I'm good. You need to make sure you take the square root of this one, the square root of this one, so the first and the last, and then in here we multiply these two together times 2. As long as this pattern works out, then we're good to go. So same thing on this one. The only difference is we have a minus here, but we still have a square and a square for the first and the last, and we're still multiplying the square root of the first and the last times 2 for the middle term. We just have a minus there instead. So again, we take the square root of both, the first and the last, and we just plug them in. And it's already factored. So it's a very quick way to factor. Is it the only way to factor these? No, but it's fast. So when we're doing larger problems that have a lot going on, we can factor this pattern very quickly if we recognize this. So let's go ahead and take a look at this guy here. So we have a square, and I can take the square root. I can take the square root of this one. And then if I go 2 times x times 4, then I do end up with 8, because 2 times 4 is 8, and then x. So this does meet the pattern. So all I have to do is focus in on first and last. So since it was plus and plus, it's going to be x plus 4, and I'm done. All right. Next one, we have square root of b squared, square root of 25, and then in the middle here, I'd have 2 times the first times the last. 2 times 5 is 10, and then we bring the b in. Happy day, it meets our pattern. So I go first and last, but make sure you pay attention. There's a minus sign there, so that means minus in the middle. Alrighty, let's go and practice some more on these next few pages here. Actually, this is the bottom half of that page. I just have separate pages on mine. Make them a little bigger, a little clearer. So determine whether 81x squared plus 90x plus 21 is a trinomial. Write yes or no. If so, factor it. So let's go ahead and write it down here so that I have a little bit more room. Plus 25. Alright, so square root of 81 is 9. Square root of x squared is x. Square root of 25 is 5. So far, so good. We have a square and a square. But we need to check the middle. So we'd have 2 times 9x times 5. So simple one to do would be 2 times 5, and that gives me 10, times 9, and that gives me 90, 90x. So check. Yes, this is a perfect square trinomial. Or just a perfect square, I guess you would. I don't know if you necessarily need to add in the word trinomial there. So we're going to go ahead and factor it. It's all plus, so I know it's going to be plus in the middle. It's also going to be square. Don't forget that little square when you're typing this in. First, last. And it's factored. So on this one, you may have to put in 2 answers on our online program, Alex. You're going to have to answer yes, it's a perfect trinomial or a perfect square, and then you're going to have to factor it. Okay? And then if you do say no, which may very well be on the next one here, usually we have one of each, then if you do choose no on the online program, you wouldn't fill in the equation part. It just wouldn't, like it would probably be grayed out, is what it would do. All right, so 4x squared minus 42x plus 110. So with this one, we have 2x because square root, square root. Can we take the square root, the even square root of 110? Nope. We can take the square root of 110, but it's not going to be an even number. We want these to be perfect squares. We don't want decimals in here. So we would just say, no, this is not a perfect square. All right, we're going to keep moving down here. We have a couple more. I believe, yeah, these will be the last 3 for this section. So factor the polynomial 2b squared plus 12b minus 24, if possible. If the polynomial cannot be factored, write prime. So we're kind of going back to our regular factoring here. This is not a perfect square, not a perfect square. So we're not practicing necessarily the actual perfect square process in this one. We're just going back to regular factoring. So let me write this down here so I have it. So what we want to do when there's a number on the front, when we have a coefficient, we, instead of just looking at the factors of 24, we're going to do, this is A, B, C. So we're going to do the factors of A times C. So that's 2 times 24, which is 48, right? So 1 and 48. And we get, oh, you know what? Actually, I just noticed an easier way to do this. I'm fibbing to you. So we can actually, it's 2, 12, 24. They're all even. I can divide all of these by 2. So let's do that, because that's a little easier than dealing with the 48. So 2b divided by 2b squared divided by 2 is just b squared. 12b divided by 2 is 6b, and 24 divided by 12 is 12, or divided by 2 is 12. Getting tongue-tied there. All right, so now we can just look at the factors of 12, because it would be 1 and 12 for A and C, but 1 times 12 is just 12. So the factors of 12 are 1 and 12. You always have 1 in the number. That should be your first one. The next one is going to be 2 and 6, 3 and 4. So these are the only ones. The next one we come to would be 6. Well, we don't have to write that down again. Or the next one we actually come to would be 4, because it would be right after. But we don't have to write 4 and 3 again. All right. So what we do need to pay attention to is there's a negative here and a negative here. So what that tells me is that I'm multiplying a negative and a positive to get this 12. Because that's the only way to get a negative when you're multiplying. We're going to have a negative and a positive when we factor this. So it would look like this. Plus, minus. And this would also be b and b, because that's the only way to get b squared. So it's nice when there's no coefficient on the front, we just break it down into b times b. So I need the factors that add up to 6. That's what I'm looking for. So we go through, we look at these. Well, none of them add up to 6. This is 7, or subtract a 6, because actually it's plus and minus. So they would have to subtract down to 6. So this would be 1, this would be 4, this would be 11. None of them can go this direction. So this would be prime. Because I can't evenly factor this. Doesn't mean it's not factorable. It just means right now I can't do it with integers. I have to use decimals, and we'll start to deal with that later in the chapters. So don't worry about that right this second. We'll get there. We will. All right, so we are going to go to the next two problems, and it's a little different looking. So use the square root property to solve the equation, and we haven't talked about this yet. The square root property says I can take the square root of both sides of an equation. And it's one way, if we had this same problem, but I'm going to simplify it really quick, so just give you an example. If I had x squared equals 100, well, if I want to know what x is, I would take the square root of both sides, and I'd say x equals 10. Because the square root of x squared is x, the square root of 100 is 10. So it's the same exact idea when we're dealing with this one, except now we have a binomial that is being squared, and that equals 100. But we would still do the same thing. I'm going to take the square root and the square root. So the square root of x squared plus 3 squared is x plus 3, equals the square root of 100 is still 10, but it's plus or minus 10, because 10 times 10 will get me 100. Negative 10 times negative 10 will also give me 100. So keep in mind, it needs to be two answers. We should have two roots because it's a square. Okay? So that helps us get our two answers. So that means that I'm going to have two equations. I have x plus 3 equals 10, and I have x plus 3 equals negative 10. So I need to solve both of these. So I'm going to subtract 3 from both sides. 3 minus 3 cancels, and I end up with 10 minus 3, which is 7. I'm going to subtract 3 from both sides again. 3 minus 3 cancels, but this time it's negative 10 minus 3, so I combine them and keep the negative sign. So I have two roots like I expected here. These are the two places that it would cross the x-axis if I graphed this, would be positive 7 and negative 13. Okay, so we are going to do the same thing on the next one here. We're going to have z plus 5, whoops, not square rooting it yet, and we're going to take the square root of both sides. There we go. So this would be, and I'm going to cross this so that you know that's a z. My z's kind of look like 2's. Equals, we don't want to take the actual square root of this one because it would be a decimal. So we don't want to do any rounding mid-problem. You really want to be careful about that, because especially on the online program, if you round mid-problem, you're probably not going to get the correct answer at the end because it'll be too rounded. I know that sounds funny, but you don't want to do any rounding mid-problem like this. So we're just going to say plus or minus the square root of 47 instead of actually taking the square root and getting a decimal. Because it's close. 49 would have a square root, but 47 is going to have a decimal root. All right. So we have our two problems. We have z plus 5 equals 40 square root of 47, and z plus 5 equals the square root of 47, but we have a negative in front of here. So I'm going to subtract 5 from both sides. Z equals the square root of 47, and whoops, changed my color there. 47 minus 5, and then I'm going to subtract 5 from both sides over here. And I have z equals negative 47, square root of 47, minus 5. So they're still both minus 5 there, but I have positive square root of 47, negative square root of 47. So these are my two roots. For right now, I would leave them like this. Like I said, I would not turn that into a decimal unless you are instructed to do so on Alex. So if it's not giving you any rounding instructions, definitely leave it alone so that you don't get marked wrong for something like that. All right, well, that is the end of section 9. I will see you in section 10.